Hello students, here I am to discuss the test paper, the analysis of JEE Main 2026 held on 23rd of January 2026 in the morning session. Okay, so here we go. So started with the first question. A rod of mass m and length L is rest in a region of uniform horizontal magnetic field. Find the induced EMF in the rod after falling a distance x. Okay. So here, suppose if this is the rod which is falling and horizontal, so this is the vertical plane, so any plane will be horizontal. So let us say this is the horizontal field. Okay. The direction of field will be horizontal, that is B. Now, since this rod is falling from a height h under gravity, because obviously this loop is not there, so there will be no induced current, so there will be no magnetic force. The only force which is acting is gravity, and because of gravity, it is acquiring some velocity. So you know that when the body is doing free fall, what will be the velocity after falling by a distance x? It will be equals to root 2 gx. And now therefore, we can find out the induced EMF, which is the motional EMF here. Induced EMF, which is the motional EMF here, is BVL. So just substitute the value, it is BL, and the value of V is root 2 gx. Is my right answer, the option 3. I move to the next question, quite easy question this is. Okay. Find the capacitance C for the given circuit. Okay, so they have not directly giving you the information in the language. So it is a simple LCR circuit with AC source. And if you look into the voltage part, this voltage, so voltage is given to you as V0 sine of omega t. And correspondingly, I is given to you as I0 sine of omega t. So clearly you can see that the phases are same. Both the phases of voltage and the current is same, which is in case of LCR circuit is only happening in case of resonance. You know that in case of resonance, what will happen? That both voltage and current are in the same phase, which means XL is equals to XC and XL equals to XC. So I can write down omega L is equals to 1 by omega C, and to get the C, we can write down as 1 upon omega square L. Now the omega value is 100 radians per second. Just substitute this value. So it is 1 upon 100 square into L. The inductance is given to you 20 Henry. So it is SI unit 20 Henry. So now this is going to be 1 by 2 into powers are 1, 2, 3, 4, 5 minus 5. Which you can write down as 5 into 10 to the power minus 6 farad. 5 microfarad is your answer for this question. 5 into 10 to the power minus 6 farad. Okay, again move to the next one. Again, this is an easy question. Okay, resonance direct condition. Okay, now this question is little lengthy. The moment of inertia of the cylindrical rods. So you first name them as 1, 2, 3, 4. So if I name this as 1, this as 2, this as 3, and this one as 4, and the corresponding axis will be y dash. Then about y dash, we can say the moment of inertia for 1 and the moment of inertia for 3, that will be same. Whereas the moment of inertia, because of the portion 2 and because of the portion 4 is also same about the axis y dash. Alright. So let me calculate I1 and I2 in a separate calculation, and then the I of this lamina, I of this structure about y dash, we can directly write down as twice of I1 plus I2. Alright, because I3 and I4 is equals to I1 and I2. So for I1, so for the first one, so first one is a cylindrical rod. It is a cylindrical rod for which this is the first rod, and y dash will be perpendicular to its length passing through the center. That means this is a solid sphere, so we write down this I1 as mass m dash. I will tell you why I am taking m dash, because m dash is given to you as m by 4. The total mass is m, so each rod is having the mass m by 4, and that's why this is m dash into, first it is the disk about the diameter. About the diameter it is r square by 4, plus about the center this is behaving as a rod, so for rod it is L square by 12. Alright, and similarly I2, so let's look into the I2. So second portion I am taking a vertical cylinder, so this is the axis of vertical cylinder, and y dash, the axis will be at a distance L by 2. So now in this case you have to consider this solid cylinder as a rod, as a disk passing through the center and perpendicular to the plane. That means this is also m dash into r square by 2, that is for the disk which is passing through the center and perpendicular to the plane. And now you have to shift it by the parallel axis theorem, so it is plus L by 2 whole square. As far as the rod is concerned, the axis is passing through the rod, like it is along the length, so there will be no need to take that in consideration. Alright. Now, if I substitute these values, I am getting 2 into m dash. Now this is r square by 4 plus L square by 12. And in I2, this is r square by 2 plus L square by 4. Substitute the value of m dash. So this is given to you m by 4 into 2, that is m by 2. Now r square plus r square by 4, this is 3r square by 4. L square by 12 plus L square by 4 will be L square by 3. Alright, and therefore it is going to be 3 by 8, the first term is 3 by 8 mr square, plus the second term will be ml square divided by 6. That will be your I of this combination of 4 rods, cylindrical rods, about y dash. So let's match. So 3 by 8 mr square plus ml square by 6. Okay, option D. Option D is the right option for this. So quite lengthy, so we will keep it in the moderate category. And you see, moment of inertia is coming in almost every test. So it is quite an important topic from the rotational motion. So rotational motion questions are coming, but not very difficult. Moment of inertia, in almost in every test they are giving moment of inertia, and I think this question is the little lengthy. Rest of them is even simpler also. Okay, let's move to the next one. Okay, now here there can be some, because it is memory based, so there will be some information will be wrong also possibly. So whatever is given, whatever information is given, we will solve it accordingly. Okay, so here they are saying that there will be a pendulum which is being released. There will be a pendulum which is being released from the point A. So it is a simple pendulum. When it reaches to the bottom B, what is its velocity at that time? Its velocity will be simply mgh. So this velocity when it reaches to the point B is under root of 2gh, and this angle is given to you 60 degree. That's why this length is L by 2. So h is also L by 2. That means this value is going to be root GL. Root GL. L is given to you 1 meter. So I can just write down as root G. What will happen when this A reaches to the point B? When this A reaches to the point B, when this A reaches to the point B, at the lowest point its velocity is also horizontal. It strikes to the another particle which is also identical. So A and B are identical. So this is striking with the velocity VA, and elastically they are striking. So now you know that in elastic collision, if both the bodies are identical, the velocities interchange. So this is the situation which is before the collision. And now this situation after the collision will be what? A comes to rest. A comes to rest after the collision while B start moving with the velocity root G. Alright, root G. So now this B has to, after B is getting this velocity root G, it has to complete this circle. It has to complete this circle of radius R. Reason they are asking that so that it will pass through this point C. Suppose if it wants to pass through the point C, then definitely it has to pass through the point P first. And this is now a simple case of vertical circle, that if I say what is the minimum radius R, I will say this velocity which is at the lowest point, this VB dash, which is root G, should also satisfy root 5GR to complete the circle. And therefore, if I square on both the sides, G is equals to 5GR, and this R is nothing but 1 by 5. So 1 by 5 meter is the minimum radius of this circular motion, of this circular track, so that B will be reaches to the point C. There might be a possibility that there will be some mismatch from the actual paper. Maybe this 3 point becomes the highest point, whatever it is, but as per the given data, this will be your correct answer. Okay, R equals to 1 by 5. So we are going with 1 by 5, that is option A. Move to the next one. Okay, now again, this is also a little calculative. So, but the best point is this, that they are talking about that this is the transition of the electron from second to 1. So, higher state is 2 and lower state is 1 in all the cases. And you know that the energy which is being released will be higher minus lower. So, I am going to write down this energy gap for hydrogen-like atom, for which this is going to be minus Z square into 13.6 divided by 4 by 4 because it is 2 square, minus minus becomes plus, that is Z square into 13.6 divided by 1 square, which is 1. So 1 minus 1 by 4 will give you 3 by 4. So 3 into 13.6 divided by 4. That value will be 10.2 into Z square. That means this value comes 10.2 into Z square EV. So I calculated this value first, and then now we will check. Okay, why I fix the higher orbit and lower orbit? Because every case I have seen that it is 2 to 1. So you don't need to do this calculation again and again. You have to just now put the different value of Z for the cases and you can do your calculation quickly. So let us say if I am talking about the part A, it is hydrogen. Hydrogen means Z is equals to 1 only. So that means your delta E is going to be 10.2 EV for the first case. For the second case, we are talking about lithium 2 plus. Now see, even if you don't know the atomic number, you know that 2 plus means 2 electron is went. So it is hydrogen-like atom now. That means that is equals to 3. So clearly your delta E is equals to Z square, that is 9 into 10.2 gives you 91.8 EV. Alright. Again move to the next one, that is C part, that is helium. Helium 2 plus. Helium 2 plus transit from 2 to 1. So again for helium, your Z value will be, helium 1 plus, yes. Helium plus means one electron is out, one electron is there. So Z is equals to 2. That's why what is delta E for helium? It is 4 times of 10.2 comes out as 40.8. Right? And that is the answer, as you can see that. And let's check the D also, so that we will be sure. Though sometimes during the exam you don't need to. Just I am checking here. So it is 3 plus. 3 plus means 3 electrons is out. So Z value will be what? 4. And Z value will be 4 means delta E is 16 times of 10.2. 16 times of 10.2 gives you 163.2 EV. So as you can see, this is not matching, this is not matching, this is not matching. The correct answer is C. So I would say it is little lengthy as per the calculation, but see, we try to reduce it. If we see carefully that it is all the cases are transit from 2 to 1, you do this calculation separately, then it is just Z value which you have to keep it. Alright, it will make your calculation little fast. Move to the next one. Okay, find the angle A for the second prism so that the light suffer dispersion without deviation. So I should know the formula of deviation. The deviation formula will be mu minus 1 into A. And since you can see this prism will be inverted and combined, so if I am talking about deviation produced by 1 and deviation which is produced by 2 by the second prism, then it will be mu1 minus 1 into A1, mu2 minus 1 into A2, and they will be reverse. Because of the combination, they will be in the opposite orientation. If one is clockwise, another one is anti-clockwise. So to make it net deviation to be 0. So if I want to make the net deviation to be 0, means magnitude wise, they will be equal. And obviously one is positive sign, one is negative sign. Why? Because their orientation is different because of this combination. So I am just substituting this value mu1 minus 1 into A1 is equals to mu2 minus 1 into A2. Now what is your mu1? Mu1 is 1.72 minus 1 into A1 is 5 degree is equals to mu2 is 1.9 minus 1 into A2. A2 we have to find out. So this is going to be A2 is equals to 0.72 into 5 divided by 0.9. This is 3.6, 0.3, 3.6. Okay, this is 3.6. 3.6 divided by 0.9, which is 4 degree exact. So correct answer for this question is 4 degree. 4 degree is the right answer, option B. Okay, easy question again. Move to the next one. Okay, there are 2 spring block system. So as diagram is given, 2 block system, and they are in equilibrium. So each one individually is in equilibrium. So if I say what is the condition of equilibrium is given by the free body diagram. So on the block, if you see that forces are mg and forces because of the elongation is kx. That means if it is in equilibrium, these forces will be 0, net force will be 0, which gives you the elongation in the spring as mg by k. And they are talking about the energy is stored in the spring. So if I am talking about energy which is stored in the spring, that is half kx square, depending on elongation. So at equilibrium, you already got what is the elongation. That means it is also giving you the energy as half into k into mg by k whole square, which is your m square g square divided by 2k. M square g square divided by 2k. Now it is simple comparison. So if I am talking about, okay, they are representing it by E1. So if I say U1 by U2 or E1 by E2, they are representing this energy by E. So I will also replace it by E. So they are talking about E1 by E2. ratio of E1 by E2, first string to the second string. Then masses are different and K is different. So that's why you can say that this is directly proportional to M square by K. That's why this ratio thing will come as M1 by M2 whole square and K2 by K1. Now what is M1 by M2 is given to you as alpha. So alpha is square. What is K1 by K2? This is given to you as beta. That's why the correct answer should be alpha square by beta, which is option 1. Okay, again the easy one. Move to the next question. Okay. So masses M and 2m are connected by a massless rod of length L, angular momentum. Again, so this time again rotation. So I have seen that from 11, so many questions are there, and from mechanics especially. Okay, so angular momentum about the axis passing through the center of mass. So obviously there are two ways to solve this question. That they are, first you calculate the position of the center of mass, where is the center of mass lies, and then after get these distances d1 and d2, whatever is this distance d1, whatever this distance d2 about the center of mass, and then you can write down mvr or mr square omega as the angular momentum. This is one of the way. Or otherwise you also know that there is another way which is called as a concept of reduced mass. So here I am going to solve this by reduced mass. So what is the reduced mass here? Reduced mass will be m1 m2 by m1 plus m2, which is going to be 2m into m by 3n, that is 2m by 3. The advantage is that reduced mass concept, you can treat this entire mass as a reduced mass, which is mu, which is moving with a distance at a distance d, it's about the axis, which is at a distance d with the angular velocity omega. So now here directly we can write down the angular momentum of the system, which is given to you as L, as mu into means mvr means mr square omega. So it is m into d square into omega. That means what is omega? Omega is L upon mu d square. Substitute the value of mu, which is 2m by 3. So it is 3L by 2m into d square. 3L by 2m d square. Again, we are going with the option 1. Option A. Option A. Alright. So this concept is really very well worked for you and save your entire time. How quickly you can do this question? It's very easy. Concept of reduced mass. Okay. Move to the next one. In double slit experiment, I was talking about 11th. Now question is from 12th. Okay. So Young's double slit experiment with two different setups, fringe width are equal. Fringe width are equal. So what is the expression of fringe width? Fringe width beta is given to you as d lambda by d. Okay, this is the expression. Now they have given two setups, two different setups, and they are saying as given that beta 1, the fringe width are same. So in case 1 and in case 2, fringe width is same. And if the fringe width is same, with different ratios, we will say d1 lambda 1 by small d1 is equals to d2 lambda 2 by small d2. What we have to find out is the ratio of the screen distances, means you have to find out the ratio of capital D1 by capital D2, which is here is going to be D1 by D2 into lambda 2 by lambda 1. Okay. So ratio of the slit separations is given to you as 2. So this is given to you as 2, and ratio of the wavelengths is given to you 1 by 2. So this is 1 upon 1 by 2. Which is 4. 2 into 2 is 4. The correct answer is 4. We are going with the option D in this case. Okay, very simple again. So quite easy. Till now, some of the questions are calculative, but concept-wise or are straightforward, easy questions. Okay. Another nice question. So a rod is of mass m and length L is released from the position. Fine. So this time they have given so many vertical motion. Okay. Vertical circle questions. Released from the position shown in the upper end in a uniform magnetic field. Find the maximum induced EMF. So first we should know that if a rod is rotating about one of its end, then in the magnetic field, then you should know that induced EMF will be BVL. Means BVL, when you calculate by the integration, what is BVL will come? It is coming as B omega L square divided by 2. All of you remember this? A B here is not changing, length of the rod is also not changing. That means omega is only changing. So if I am interested for E max, then it is corresponding to omega max. As this rod is moving in a vertical plane, this omega s keeps on changing, and if this omega s keeps on changing, I will be looking for the position where its omega is maximum. Here we are calculating the induced EMF, but this rod is not making any loop. Okay, this point is need to be considered. This is not making any loop, so there will be no induced current. So there will be no magnetic force also, right? So I can, to find out omega maximum, I can simply follow the conservation of energy, and conservation of energy will give me omega. So suppose if a rod is being released from this position, okay, rod is being released from this position and making an angle 60 degree, then you very well know that it is getting the maximum omega at when it becomes vertical, when this rod becomes vertical. This rod becomes vertical. That means omega is maximum when this is passing through the vertical position. So it is conservation of energy now. So to write down the energy of this rod, the change of potential energy of this rod, which is the gain in kinetic energy, then for potential energy I have to see the center of mass. Now center of mass is, this is L by 2. So this height will be L by 4. Correct? This height will be L by 4. So I can say that it is mg into the change in the position of center of mass is L by 4, which is going to be half into I omega square. Now it is in pure rotation about this point O, that's why it is ml square by 3 into omega square. This is how you are getting your maximum omega during this motion. And maximum omega will be mm cancel, 1l cancel, 2 cancel, so it is 3g divided by 2l under root. Okay, under root of 3g by 2l. Now substitute here. So for getting this E max, the maximum induced EMF, we are saying B into L square by 2 into omega. Omega is root 3g by 2l. Okay, so let's convert it into this form. So if I am converted into this form, B into L is outside. So that means I am taking this L by 2 inside. So L by 2 means L square, 1 L will cancel, these L's are same. This L is same. So it is going to be 3GL, 1 L cancel, okay. And this 2 will go inside, so it is 4. So 4 into 2 is 8. Okay, that will be my right answer. So BL under root of 3GL by 8. That will be your right answer. So we are going with the option A. Okay, so very good question. So I'll keep it in moderate category. Nice question. Move to the next one. Two mediums of refractive index N1 and N2 have the plane surface. In the first medium, the speed of light is 2.4 and second medium. So speed of light is given and critical angle you have to find out, right? So suppose if there are two mediums, N1 and N2, light is traveling and let us say this is traveling with V1 and V2. Okay. Then you should know that refractive index is given by C by V. So that means I can write down N1 by N2, that is equals to V2 by V1. Up here you have to see that which velocity is more. So since V2 is more than V1, We can compare. V2 is more than V1. That means N2 is less than N1. So denser medium is N2. Denser medium is N2. And that is why we can write down N1 by N2 is coming out to be 2.8 into 10 to the power 8 divided by 2.4 into 10 to the power 8, that is 28 by 24. If I simplify, it is 7 by 6. 7 by 6. Alright, 7 by 6 is it? So correct. So N1 is denser and N2 is rarer. Okay, so this diagram also I will change. Why I am changing this diagram? Because as per the diagram, it is going from denser to rarer, means this ray should come like this. This ray should come like this. Okay, though the ray diagram doesn't matter in this case, because we have to just only looking for the values. As per critical angle is concerned, so directly we can use the formula. It is sine inverse of 1 upon mu of denser to the rarer. That means it is going to be sine inverse of N2 by N1. N1 is denser, N2 is rarer. That is why what is the value of N2 by N1? It is coming as sine inverse of 6 by 7. Sine inverse of 6 by 7 is my right answer. I am going with the option C. Okay. So there is no need of ray diagram. You just calculate the value. But yes, while writing down this critical angle, just decide which is the denser medium, which is the rarer medium. Sorry. Move to the next one. So very easy question this is. Okay. Screw gauge. Fine. So the question from the instrument, measuring instrument, the screw gauge has the least count. Fine. So least count is directly given to you. Least count is directly given to you. No need to calculate it by number of divisions and all. So least count is directly given to you. Using this screw gauge, the measurement is done. When nothing was present between the jaw, then also the circular scale and reference line is not matching. That means it is having zero error. It is having zero error. When nothing is between the jaw, the reference line is not matching to each other. That means if this is my reference line and this is your circular scale, then they are saying from the reference line, this circular scale 0 will be above. This circular 0 will be above by 3 division, by 3 units. Okay, so it's like this. So it is above by 3 units. That means when the reading will come, then first it will come to 0 and then it is taking the reading. That means how much is this error? This error is considered to be negative. Zero error. Okay, I will explain again. Since this 3 unit is above, so when the reading will come, when something will be put between the jaws, when the reading will come, first 0 will be coinciding, then it is taking the reading. That means the measurement reading will be less than the actual. So it is a negative 0 error. That's why we have to add it. We have to add it later on. So anyways, so if I calculate what is the 0 error, what is the value of 0 error? Negative 0 error. Then this value will be, negative 0 error value will be 3 unit into least count, which is coming at 0.03 mm. 0.03 mm. Now let's talk about the measured value. So what is the measured value here? You know that measured value will be given as main scale reading plus division which is coinciding into the least count, that is a vernier scale reading. So here main scale is what? Main scale reading will be given to you as 1 mm. This is 1 mm and 51 division is coinciding into least count, that is 0.01. So I am going to get 1.51 mm. Alright. This is the measured value. Now, what is the actual value? Actual value will come after compensating zero error. So, what you have to do with the zero error? You have to add it because it is a negative zero error. So, that's why I will say it is 1.51 plus 0.03. And this will be equals to 1.54 mm. 1.54 mm is my right answer. So, I am going with option 1. Alright, option 1. Okay, let's move to the next one. Okay, so from the instrument, this is very familiar again. If you did the instrument properly, this is a very common one. Okay, common question. Move to the next one. Okay, I think easiest question of the test. The stress and strain graph of the material is shown in the diagram. What is the Young's modulus? So it is stress upon strain. Stress upon strain. So Y is equals to stress upon strain, which is nothing but which is the slope of this graph. Slope of stress strain graph. So here, since it is a straight line, you can take any of the section to find out it is 1 by 1 or 2 by 2 or 3 by 3 or 4 by 4, all are giving you same value. So 4 into 10 to the power 8 divided by 4, that is giving you 10 to the power 8 Newton per meter square. Okay, Newton per meter square will be your answer, 10 to the power 8. We are going with the option A. Okay, simplest question, very easy. Okay, move to the next. So this time this test is not having logic gate, but still it is having one question in almost every test. You are always getting 1 or 2 questions from semiconductor. Okay, and very basic questions. No need to go into deep theory or complex circuit. So even from the logic gate also you are getting simple question, and this is also now not from the logic gate but from the Zener diode. And Zener diode concept is also very simple concept, very basic question also this. A little bit observation is definitely required here. So this diagram I will make it here so that it is more visible. This is your Zener diode. Its work in the reverse biasing. Then this is the corresponding circuit. Okay, the Zener diode is 5 volt. That means this potential is plus, this potential is minus, and it is maintaining this potential as 5 volt. Now IL will be 5 milliampere, and since this is your IZ, the current which is passing through the Zener diode, IZ. External load is RL, this is RS, and this is 25 volt. If this voltage will be 5 volt, you know that Zener diode breakdown voltage is 5 volt, which is maintained, and current will be there. So what is the information which is given to you? Given to you that this IZ is equals to 4 times of IL. That means IZ value also we can find out as 20 milliampere. So overall current which is passing through this RS, the overall current will be calculated as IZ plus IL, that will be equals to 25 milliampere. Alright. Also, this voltage is 5, so you can easily find out the voltage across this RS. If I named it as Vs, then this Vs is nothing but this is 25 minus 5, which will be 20 volt. Now you have the voltage, you have the current which is passing through RS. So Vs is equals to I into Rs. I can easily find out the value of Rs, which is 20 divided by I, which is 25 milliampere, 10 to the power minus 3. So it is 0.8, 20 by 25 is 0.8 into 10 to the power 3 is 1000. 0.8 into 1000 will give you 800 ohms. 800 ohms is the right answer for this question. Okay, they are asking RS. Suppose if they are asking RL also in the question, then that also you can find out, because you know that voltage across the RL is VL, which is 5 volts. Now this is also IL into RL, that is equals to 5. This is RL will be 5 upon 5 milliampere, so it is 10 to the power minus 3, gives you 1000 ohm. Alright, 5 upon 5 milliampere will give you 1000 ohm. So here in this question, the correct answer is 800. Okay, I just added on one more thing. Because it is memory based, you don't know, maybe they are asking RL, so I calculated that value also. Okay, so now this question based on errors, right? So they are asking for the relative error for the set of measurement. So if you see the values, first we need to find out the mean value. Mean value means what? Mean value means summation of all the values divided by n. So when we do this, this is 20.00 plus 19.75 plus 18.25 plus 17.01 divided by 4 gives you 75.01 by 4, which is equals to 18.75. All right. Now the relative errors. So first you find out the individual errors. So individual errors, when I calculate, it is how to calculate that delta x. Delta x you calculate as x mean minus that corresponding value, whichever is greater. So your corresponding values is coming out to be 20 minus 18.75 means first one is 1.25. With the second, if I am doing, it is 1. Third one is giving you 0.5. And fourth one is giving you 1.74. So these are your errors for the corresponding 4 set. Now, if I am talking about absolute mean value, mean absolute error, then mean absolute error will be going to be the sum of this divided by 4, which is giving you as 1.12, which is coming out as 1.12. Now we have to find out the relative error. So for relative error, we can write down delta x mean upon mean value. Okay, it is not the percentage error, it is the relative error. So no need to multiply 100. So it is 1.74 divided by 18.75, and this value comes out to be 0.06, which is option B. Okay. Move to the next one. Figure besides represent strain versus stress graph. Noted, strain versus stress. And they are talking about maximum Young's modulus. Young's modulus is stress upon strain. Stress upon strain, which is the slope of stress strain graph. But here it is given to you strain stress graph, so I will say it is 1 upon slope of strain stress graph. Yes or no? In this you can clearly see that the slope of D is maximum and the slope of A is minimum. So whatever slope is minimum, that will be having maximum y. So here YA is maximum, then YB, then YC, then YD. And they are asking for maximum, right? So what is maximum? Maximum is A. So we are going with the option A. Very simple, but yes. Sometimes in the simple question, student made a mistake. If you don't notice this, that this is strain versus stress graph, unnecessarily you are going to lose the super easy marks, which is 4 marks, means very, they just want to gifted you these marks. But you have to be careful while reading it, okay? Next one. A simple pendulum of length 30 centimeter makes 20 oscillations in 1 second. Okay, so there are two pendulums are given. So what is the time period of the first one? It is 10 seconds. It is taking for 20 oscillations. That means the time period per oscillation will be 1/2. Similarly, the another pendulum is making 40 oscillations. 40 oscillations के लिए it is taking how much time? It is taking 10 seconds. So its time period per oscillation will be 1/4. Alright, this is the time period. Now they are talking about the length. So if I say what is the time period expression, it is 2 pi under root of L by G. Now the length of the first one is given to you as 30 centimeter, and we have to find out the length of the second pendulum. So I think we can easily go with the ratio thing. So what is T1 by T2? T1 by T2 is equals to under root of L1 by L2, because rest 2 pi by G, this is common. So now here I can write down L1 by L2 is equals to T1 by T2 whole square, which gives me this L2 is equals to T2 by T1 whole square into L1. Alright. So T2 by T1 is 1 by 4 divided by 1 by 2 whole square into 30. This gives you 1 by 2 whole square is by 4. So 30 by 4 gives you 7.5 centimeter. 7.5 centimeter, answer C. Okay, easy question. Okay. So, long before, around some 10-15 years before, this question came in IT, and there are different solutions are floating in the market, okay, in which some of them are wrong. Okay, so again they are repeating the same concept here. Calculation wise it is same, but when you have to combine these capacitors, you have to be very careful. So let me explain this, what is happening here. So this is one capacitor plate, this is the another capacitor plate, and in between them there are some dielectric is being introduced with different thickness and area. So this is corresponding to K1. If I named it as K1, it is 2. This is corresponding to some K2, which is 3. This is corresponding to K3, which is 5, and this is D by 2 thickness, and this is A by 2. Half of the area will be governed by these dielectric. I can consider this is corresponding to C2, I can consider this is corresponding to C3, I can consider this is corresponding to C1. So this is corresponding to C1, and if you start combining, don't go with this way. You first do this thing that you divide it into two halves. Why I am saying this? Because when the charges are induced, the distribution of the charge here is different and distribution of the charge here is different. So you cannot consider this entire thing as a single capacitor. You have to consider this half of the portion. Let us say I just named it as C1 and C1 only. Both is half C1. This because this is also the dielectric of dielectric constant 2. So if I say what is my value of C1, then you will say, sir, it is K epsilon naught A by D. Alright, this is the expression of C. This is the expression of C. This is the expression of C without the dielectric. Now, if I am talking about what about C1? So for C1, it is K1, that is 2 into epsilon naught. Now, area of this portion will be A by 2, and this is D by 2. That means I can assume this C1 as 2C. So this portion is also having 2C. This half portion is also equals to 2C. Similarly, when you calculate this C2, it comes as 3C. When you calculate this C3, it comes as 5C. Okay, same way, A by 2, D by 2 will 2 will cancel, and dielectric is different. Now when we have to combine, how do we combine this? We combine this in this way. We will assume this as C1. This is also half of the portion is C1, and it is in series. These two are in series. So C2 will be in series with C1, and C3 is also in series with C1. Like this. Alright. So this is your combination. So now C1 and C2. C1 and C2 are in series. C1 and C2 are in series. So what will be the series formula? C1 C2 upon C1 plus C2. That means 2 into 3 by 5. 2 into 3 by 5. That is 6C by 5. Okay. Their equivalent will be 6C by 5. Similarly, C1 and C3. Now C1 and C3 means 2 and 5. So it is 2 into 5 by 7, that means 10 by 7. 10 by 7 into C. So this equivalent and this equivalent, now these two are in parallel. When these two are in parallel, we will write down the capacitance with the dielectric becomes 6C by 7. 6C by 5. 6C by 5, put the correct value. 6C by 5 plus 10C by 7. LCM is 35. 7, 6, 42 plus 50 into C. This comes as 92 by 35 into C. 92 by 35 into C, right? Okay, now it is integer type. So what they are saying? If the capacitor becomes NC by 3, if this value will be equals to NC by 3, what is the value of N? So CC cancels. So what is the value of N? It is 92 into 3 divided by 35. Calculate this value. It is coming something around 7.9. Is it? Yes, 7.9, which is approximately nearest integer is 8. So the correct answer for this question is 8. Okay, the correct answer for this question is 8. All right, some calculation is there. A nice question, moderate question. Okay, move to the next one. Find the de Broglie wavelength of the oxygen molecule. Oxygen molecule, not the atom. At temperature 27 degrees centigrade. 27 degrees centigrade. All right. So what is the kinetic energy of the molecule? That is 3 by 2 kT. All right. And now they are talking about molar mass is also given. So what is the mass of one molecule? What is the mass of one molecule? It is the molar mass divided by Avogadro number. Okay, or 1 mole. Now de Broglie. Okay, so de Broglie wavelength. So de Broglie wavelength is given by h by momentum, or momentum we can write down h upon under root of 2mk, 2mke. Now substitute all the values and get your answer. Okay, so this is going to be 6.63 into 10 to the power minus 34 upon under root of 2 into m. Molar mass is given to you 32 divided by Avogadro number, that is 6.63 into 10 raised to the power 23 into kinetic energy is 3 by 2 kT. Some 1.38 into 10 to the power and T is given to you 300. All right, this is okay. So after all this calculation, you will get the answer as A. What is the correct answer? A. Okay. Question from Gauss law. Flux. Okay. So what is Gauss law? The electric flux in enclosed surface. This is electric flux through enclosed surface is given by Q inside by epsilon naught. Interesting. So in this lamina, we have to find out throughout the cube, this entire cube. An entire cube, there are two charges. One is placed at the center of the face. One charge Q is placed at the center of one face of this cuboid. That means its contribution for the inside charge is Q by 2. And one 2Q is placed at the corner of this cuboid. So one is at the cuboid So its contribution inside is 1/8. So 2q by 8, that is q by 4. That means the total contribution of these charges for the cube is q by 2 plus q by 4, which is going to be 3q by 4. 3q by 4. And 3q by 4, that's why what will be your answer? 3q by 4 epsilon naught. That will be your flux. Option C. Alright? Easy question. Okay, next one. A projectile, integer type? No, objective. A projectile is projected at an angle of 60 degree with ground. Find out the kinetic energy at points B and C. Okay. So there are some points given, A, B and C. A is the point of projection, C is the point of landing. A is the point of projection, C is the point of landing, and you know that speed is same. If we are not neglecting the air resistance, which is obviously when it is not mentioned, it is being neglected in the calculations. So at the point A and at the point C, both points are having same speed. Whereas B is representing the highest point. If B is representing the highest point, the velocity at the point B will be u cos theta. You know that x component of the velocity will never change during the projectile motion under gravity. Okay, so here they are talking about find out the difference of the kinetic energy at point C and at a point A. Difference of the kinetic energy at C and at B, this is the difference to the kinetic energy at C, This value we have to find out. So if we have to find out this value, I can write down this as 1 minus kb by kc. Also, I can write down this value as 1 minus, since these are the kinetic energies, which is directly proportional to velocities square, so it is Vb by Vc whole square, and Vb by Vc whole square is nothing but 1 minus cos square theta. As you can see, the velocity as C as u and velocity as B is u cos theta. So u cancel, it is 1 minus cos square theta. Theta I think given to you in the question, yes, it is given to you as 60 degree. So you put 60 degree, you are getting 1 minus cos 60 degree, which is 1 by 2 whole square, gives you 1 minus 1 by 4 is 3 by 4. Is the answer of this question. 3 by 4 going with the option A. 3 by 4. Alright? Easy question. Next one. Find out the average intensity. Okay, so from EM waves also, and in almost in every test, one question is coming. So intensity formula is what? Average energy density multiplied by velocity, which is C, right? Which is C. So half into epsilon naught into E square. Now speed of light you can write down as 1 upon under root of mu naught epsilon naught. So this is going to be half into under root of epsilon naught by mu naught into E square. Now this is half. The value of under root of mu naught by epsilon naught is given to you 377. So it is 1 upon 377 into this is E naught. E naught is 377 as per the equation. So it is 377. 1 is cancelled by 2. 377 by 2 is 188.5. 188.5. Option A. Absolutely simple question, direct question. Okay? Direct formula based. Fine. Next one, collision. Lot of mechanics this time. Okay? So this is a perfectly inelastic collision. Perfectly inelastic collision equals to 0. Two balls made of the same material. When they are talking about same material, that means it is having same density. And as we are proceeding to this question, energy lost in the collision is completely utilized to raise the temperature. That means I am going to use the specific heat also. So since these are made of the same material, that means I will say density as well as specific heat capacity, both is same for both the balls. Alright. Now, energy lost in the collision. Now energy loss. What is the kinetic energy loss? For the kinetic energy loss, again you have so many formulas. Okay, first you calculate the final velocities after the collision, initial velocity, then final kinetic energy, initial kinetic energy. But again, I will prefer what? I will prefer the reduced mass concept, and by this we can easily find out this kinetic energy loss by direct formula, half into reduced mass into V relative 1 minus E square. V relative square 1 minus E square. Up here if you see, two bodies are moving in the opposite direction. So if they are moving in the opposite direction, what is the V relative? The relative velocity will be 10 plus 30. That becomes 40 meter per second. And what is the value of reduced mass? m1 m2 by m1 plus m2. So it is 15 into 25 divided by 40. Alright. So this is 5, this is 8, this is 75 by 8 kg. So I am going to put these values here to get the total energy loss. So it is half into 75 by 8 into 40 square into 1 minus 0. Okay. So 75 into 1600 divided by 16 will give me 7500 joules. 7500 joules is the total loss of the kinetic energy during these collision. And now both the bodies are combined. So this energy will be used to raise the temperature. That means it is equals to m1 plus m2. Now total mass is m1 plus m2. Both are of the same material, so their specific heat capacity is same, into delta T. This energy loss will be used to raise their temperature, delta T. That means this is 7500, total mass becomes 40 into 15 plus 25, 40 into specific heat capacity is given to you as 31. But since we are dealing with SI, so it is calorie. So 31 into 4.2. 31 calorie you have to change in joule. So joules means 4.2 joules per kg per degree centigrade into delta T. So here delta T is coming as 7500 divided by 40 into 31 into 4.2. That will be my answer. Calculate this value. It comes as 1.44 degrees centigrade, option D. 1.44 degrees centigrade, option D. Okay. Yes, you can say this is lengthy question, but yes, if you are very well know this reduced mass concept or remember this formula of reduced mass to calculate the loss of the energy, it hardly takes 2 minutes to solve it. Okay. So move to the next one. I think this is the last question. A circular ring and two wires AC and BC are joined as shown in the figure. Okay. If all the wires are having the resistance per unit length as lambda, why this is resistance per unit length? You see the unit, ohms per meter. So this is resistance per unit length. Per unit length. Okay, and we have to find out the equivalent resistance across A and B. Across A and B. Fine. So across A and B. So this is the terminal A. This is the terminal B. This is the terminal A. This is the terminal B. And if I can see that across AB, I will find out three wires. One is this quarter portion, one is this 3/4 portion, and one is this two straight portion, which is also. Please mind it, this ACB portion will be considered as a single. single resistance. Why? Because this is not connected to any of them, any of the terminal. This R is just denoting the radius, nothing else. This is a straight wire which is connected between A and B. So if I say between A and B, then I can say this is the portion 1, this I named it as portion 2, and this I named it as portion 3. This entire portion I named it as 3. I changed the color so you can see that clearly. Okay. This is your terminals. This is I consider as portion 1. This one, the 3/4 portion, I will consider as portion 2, and this straight wire portion I am considering as the third one, and all are across AB. So now we are finding out R1, R2 and R3. What is the resistance R1? The length of this wire is pi r by 2. So it is pi r by 2, and resistance per unit length is lambda. If I am talking about the resistance of the portion 2, which is 3/4, so 3 pi r by 2, that will be my total length into lambda. And then I am talking about the third portion, which is r plus r2r, so its total length is 2r into lambda. All are connected through AB, so that means R1, R2, R3, all three are connected through AB. That means all three are is considered to be in parallel. So if they are in parallel, we are saying R across AB, 1 upon R across AB is equals to 1 by R1 plus 1 by R2 plus 1 by R3. All right, which is 2 by pi r lambda plus this will be 2 by 3 pi r lambda, which is 1 plus 2 r lambda. So here I am going to take the LCM as 1 by lambda r. What I am going to get it from here? 2 by pi plus 2 by 3 pi. 2 by pi plus 2 by 3 pi plus 1 by 2. Now take LCM. So 1 by lambda r, if I take the LCM, it is 6 pi. It becomes 6 pi. That means 6 into 2 is 12. 3 pi, so 2 into 2 is 4. And 2, so it becomes 3 pi. Okay, and therefore, what is the R across AB? R across AB, reverse it. So 6 pi lambda R bracket, it is 6 pi. What is this total? This total is 16 plus 3 pi. That is going to be my answer for this question. All right. Lambda R 6 pi upon 16 plus 3 pi. That will be the answer of this question. Okay. So, again, a easy question. Okay. Right. This is it. So, I think this is almost all the test paper. They are very well balanced. Nothing is out of syllabus. Every question will be in the easy to moderate range. Some of the calculation might be lengthy, but yes, if you know the concept very well, you can reduce them in the easy calculation also, right? So, I hope you did well in the exam. Those who are going to appear in the coming exams, all the best for them. Okay, thank you.